What's up everyone, and welcome to this tutorial about generating random numbers. And in this video I'm just going to briefly go through the introduction of it and what we're going to cover in the coming videos. So let's say that you are familiar with generating random numbers in any programming language, and usually this means that you will use some pseudo-random generator like for example, Java's random and then get next int or get next float or whatever. Or you would use math.random in JavaScript, I think. And I mean, any programming language kind of has this legitimate thing where you can generate pseudo-random numbers with some kind of seed. So you will get random numbers basically. And the numbers that you will get from this is usually they're like uniformly spread in some interval, so they will be evenly spread within your min and max value that you have specified, right? And most of the time this is fine, of course, that they're like uniformly spread, or maybe you just want some randomness. But sometimes you would instead have a scenario where you have some value and you want some kind of like variation on that value, but not entirely uniformly random. So instead what you want is maybe something like this curve here instead, where you have a mean value, your like original value or whatever. In this case the mean here is 0, and then you want to generate random numbers with a high probability close to that value and with a lesser probability when you get away from it. And that means that if you have probability here on the y-axis, it means that you will get something like this, like a bell curve like this. And in this particular case, this bell curve is called the normal distribution. So that is called the normal distribution, or Gaussian distribution, or Gaussian distribution, I'm not sure. And then the next question comes like, okay, how wide is this curve? Where is the mean? And like how much of my data is going to be present close to my mean, and how close, and so on. And this is for this we use something called the standard deviation, which is usually signified by the sigma sign like this. So if we take a look at this normal distribution example here, it means that our mean in this case is 0, and one standard deviation positive from the mean is going to contain 34.1% of your data. And if you go out to the second standard deviation here, you will get another 13.6%, and up to the third standard deviation here you're going to have additional 2.1%. So it's very unlikely that you will get a random number that is out here, but you know it's 2.1% of your data is going to be in this section here or in this section here, right? And also you can sum them up, of course, to say that you know approximately 99% of your data is going to be within 3 standard deviations, negative and positive. So that's like a way of putting a boundary on your min and max like probabilities, but still having this like higher probability close to your mean of generating random values, right? So that is the reason for this video basically. So we're gonna see how we can generate random values according to this bell shape, right? And this bell shape is called a normal distribution, and also a Gaussian distribution, and or a Laplace Gauss or whatever distribution apparently, according to this Wikipedia article right here. So you can take a look at this, I guess, and browse through it and see if maybe you want some more in detail about this, or maybe you already know about standard deviations and stuff and just watching this for the programming stuff that we're going to get to later. So this is a good material. Take a look at this. And also another way of generating these random numbers according to this distribution. We have an implementation here of it. I'm going to use this method right here. I'm not even going to try and pronunciate it right. And apparently there is something called the Box-Muller transformation, or even the Cigarette algorithm, which is more efficient than this one that we're going to use. But for all practical reasons, this is good enough. And here's an implementation of it in Java. So I'm not going to go through this. You have the Wikipedia article here. I can read what it is about. But what it does for you is, like, you have the mean, and the mean is, like, in this case, the mean was 0, right? And you give it a standard deviation, and that means, okay, how wide is one standard deviation? Like, is one standard, you can see it's like multiplied, 1 multiplied with sigma, 2 multiplied with sigma. So, like, basically, what is sigma in this curve? And that, of course, going to mean that, like, how wide does this bell become, and how thin does it become, right? So that is the standard deviation, and then it's going to return a double for you. So what I did basically was I copy pasted this and translated it into JavaScript, because that is easier to work with in tutorials, because you can run it in your browser. So I have it on this Bitbucket snippet Yiggedime thing. I'll put this link also in the description of the video so you can check it out. But basically what you can do is you can copy paste this. And here is also a link to that Wikipedia article. You can just right click and click inspect element, and then you can go to console, and you can just, like, paste it in here and run it, and you get these values. You can test it out with, like, different values basically. So you give the mean here and then the standard deviation of it, right, like this. So let me go ahead, and I have put this, like, I have this like in a script on disk, and I like this. It's the same thing, right? And I'm gonna run it in my terminal with Node.js. It doesn't matter, but this is just for demonstration purposes. I'm gonna start with 100 values. So I'm gonna generate 100 random values. And I got this in my terminal, so I take this, right, and then I go like this, and then copy it, and then I need to paste it in here intermediately, and I'm gonna need to find and replace the dot signs with the comma signs, like replace all, and this is gonna be obvious y soon. If I paste this in Excel like this, I need the comma separator to be a comma, and it cannot be a dot sign. That if I did this, and then I do insert, and come on, insert. It unselected it. All right, so insert, and then recommended diagrams. I'm gonna take the histogram, right? So you can see, it's kind of getting there, I guess. Like, it's not as obvious as previous, but we just took like 100 examples. So let's try it again. And now this time, you instead of 100 values, let's generate 1,000 values instead. I'm gonna do the same thing. I'm gonna take this, run it in my terminal, and select all this good stuff here. It's gonna be 1,000 values in there, right? So it's gonna take a while to find the beginning of this. Where is it? There it is. Right. Copy this and remove this old stuff. Paste it in here. Find, replace, and replace all. Cover this. Now see what happens when we have more values. And then I do the same thing, insert, recommended diagrams, blah, blah, blah. So you can see what happened now that we have more values is that we're getting closer to this bell shape Yiggedime thing curve that we had in the image that we showed earlier. So this is just like, it is a probability that a value with this within this bin here is going to be present, and then we have a higher frequency of these, like here in the beginning, right? But there is no like guarantee because it's still random, so, or pseudo-random. But that is an important aspect. So it's not like you're gonna get this like perfect bell shape every time you do this, right? But it's a probability, and the more you do it, the closer. I mean, the more value you have, the closer you're gonna get to that bell shape, right? So that is the intuition. And now you probably think about scenarios that you want to use this for, right? Because you can use this in simulations in order to get some variations on your input data instead of having it like static or whatever. Or maybe you just want to, you know, introduce some randomness with this bell shape into something that you're building, right? So it has its applications, right? So the next question is, how do I find good values for the standard deviation and the mean, right? So how do I find good values for these? Because you know what, these are just numbers, you know, 100 and the standard deviation of 3. That doesn't really, you know, tell me anything. And in the next video, we're gonna take a look at how you would get an intuition of what the standard deviation is, how you would go about playing around with this in Excel so that you will find good values for your algorithm, basically. And that is basically all for this video. I hope you guys liked it. Don't forget to subscribe if you haven't, and leave a comment if anything is unclear. I will put also the links there in the description so you can check out the resources and everything. And yeah, I hope to see you in the next video where we do all the fancy demo and programming. All right, I'll see you there. Bye bye.